All right, so let me straight away jump into a demo showing you that how we have built this use case, one using a traditional approach, and other how we have applied a AI trust framework to build a trustworthy AI model. Right, so this is our Hypersense AI Studio, which is a no-code platform wherein we can easily build any AI prediction models. But at the same time, this platform also comes with all the capabilities of building a trustworthy AI model, such as it has features on explainability, it has features on identifying biasness, identifying data set drips, etc., which are all required capabilities. We require all these capabilities in order to implement the AI trust framework that we just discussed. Okay, so I already have a pipeline built on it. Let me straight away walk you through what this pipeline looks like. I think what we have done in this pipeline is this is basically a canvas where we have various different operators, as you can see, and each operator is interconnected to create a workflow. So what this workflow basically means is it starts with ingesting data. Here in our example, we are using data from 4 different sources or 4 different types of data about a customer. We just merge them all together, and then we are performing we are doing some exploratory data analysis using EDAs and data type analyzers, and then we are basically to identify if this has any issues, if the data has any issues, does it require any kind of a treatment, and we are essentially doing certain data treatment activities like missing value imputations, outlier detections, encoding, and then once we prepare the data, which we believe is representative to a customer base, we are running a classification algorithm here um, on a historical data of 1 year, where we have certain customers flagged as churners and non-churners. And then we are using these other operators to identify the biasness and seek explanation, etc. So that's what this entire workflow looks like, right? So let me give you first an overview of what data sets that we have considered here. Um, so one, we have taken data about customer demographic, which is coming from one source, and we have also taken customers' location, such as which city, which country that they live. We have taken data about their churn behavior because we have taken data about last 1 year of transactions. In the last 1 year, the customers who have churned out, they have been flagged as one, and the customers who are active, they are flagged as zero. And that flag variable of 1 and 0 has been used to train our predictive model here. We have also looked at the customers, so the services that they have subscribed to, the transactions that they have done in the last 1 year. And this data source is essentially used to identify if there are any behavioral changes that exist that might help us to predict the churners or non-churners. Okay, so we can also see how this data looks like. I think this data, sample data, we have taken 10,000 customers. We also made sure that these customers' data transactions are representative to the population. Um, so let's just look into this data, which has a demographic information. So this essentially tells you how the data is in this particular file. And using this summary metadata about this particular data set, you can understand the distribution of all the variables, and all these different statistics towards the left helps you identify whether it requires any kind of a data treatment or not. We can essentially see that there are certain um, variables which has certain missing values here, and yeah, that's pretty much the thing with this particular data set. Of course, we can look into the detailed distribution of all these variables to see if there is any skewedness in any particular variable, and what we can do about that, right? So likewise, one can analyze all these different data sources, and then sort of like identify what kind of issues that this data set has, and at the same time whether the data set that you are using is really representative to your true population or not. Okay. All right, so we have taken the data, we have studied this data, we have combined them into one. We also need to, like in any predictive model building, we also need to make sure that the data types are relevant for the kind of model that we are planning to build. So we have this data type analyzer for that purpose. And of course, you can, the next step is you also need to know that what features or what input variables that you need to have in place for you to build a more robust or high performing churn prediction model. So for that, I think we have selected certain variables that we wanted to check what is the influencing, how influencing these input variables are to the target variable that we have, right? And the other thing is we can also see the churn value, which is our target variable that we are using, is somewhat skewed. That means in our sample data that we have taken, which is representative to the population, 75% or 74% of that data consists of all the active customers. They are currently active in the system, whereas there are about 27% of the customers have churned out, right? There's no balance. Any predictive model would expect these two classes to have some balance in them. But however, we can look into the results and decide whether this lack of balance is creating any potential issue in the model or not. Okay, similarly, we have these additional influencing charts will help us understand which variables has what level of influence on the past churn behavior. I think this analysis is mostly to help you decide what variables you should definitely make it part of the machine learning and what variables you may exclude it in order to keep the model very simple. I'll not go over all the operators here, but some of the next set of operators that we have used here is to just make sure that data is void of any kind of a issue such as outliers or missing values. And we essentially also have certain variables which are in the text format. So we have used these encoders to just transform those text variables into numeric. And this is a very handy operator. It helps you to save a lot of work if you have more such variables in your data set. So we have built a churn prediction model here using this classifier. You just a drag and drop, you select the specific variables here, and then you can see how the model has performed across different evaluation metrics here. I think one of the key point I want to highlight here is how this what the overall accuracy of this model is about 99%, and this model is also accurate on the test data or the validation data about 96%. So it's extremely well learned model, I would say. This is how traditionally the model is built. I'm yet not explaining how we are applying the framework in the moment. I'll come to that in a moment, but I just wanted to show how someone would traditionally build an robust churn prediction model, right? So we have a churn we have a decent well-performing churn prediction model here, and we additionally use these operators to basically assess whether this has any biasness or whether or let's understand how each, now you have a model in place, how each variable is contributing to this model, right? So we can look into this chart to mainly understand at a overall level how variables are impacting, say, the customers not being churn and customers being churn. Let me select the class one, and the class one indicates the customers who are predicted to be churn, and we can see the variables such as satisfaction. Let me hover over here, and then so the variables such as satisfaction score, the variables such as number of referrals, online security, monthly charges, etc. All these different variables has are influencing for the prediction of the churn behavior. We can also look into when we know that, say, satisfaction score is an important variable for the churn prediction, we can try to understand how that behavior is. So, for example, we can see, higher, lower the score, higher likelihood of churning, and higher the score. That means the more happier the customer is, they are not likely to churn. It's kind of obvious. We can also see how the tenure behavior is expected to impact the probability of someone churning. So mostly the new customers who has a smaller tenure, they are more likely to churn versus the older customers. Okay, this is also kind of obvious. So this sort of like confirms that we have a very high performing model, but it also has captured the nuances in the data quite well, right? We can also see the number of referrals. I think what is interesting in the number of referrals is those who have zero referrals, they are slightly less likely to churn. Those who have very high referrals, they have very low likely to churn. But the people who have made referrals of one or zero in the past, they are more likely to churn, right? That's very interesting behavior in the data. Right. In the same way, we can look into specific explanation of each individual customer. So if we believe there are certain high value customers, we can see how the model is behaving among those high value customers. Now, high value customer is just one example. You can also look into any of your targeted segment of customers to see how the churn model is behaving, right? For example, the record, the record or the specific customer that I selected here, let's assume for this conversation that these are the high value customers. So this, and what we have seen is for these high value customers, we have seen the model is not predicting correctly. Like in their past behavior is churn, and the model is predicting them to be active, right? So that's completely opposite, which is a false negative in this case. And we definitely do not want to miss our high value customers as a result of the misclassification that this prediction model is doing, right? So keep in mind, we have a model which is very extremely robust. We have an accuracy of 96%, but that 4% of misclassification, we don't want to lose our high value customers as a result of those 4% misclassification, right? So using this specific feature of this tool, you can seek explanation. You can try to understand why model is predicting them to be active. Let's look into that. Okay, we got the results. We have seen previously that some of the key variables that our model is using to predict churners is satisfaction, number of referrals, monthly charges, etc. Now, since those being the key variables, what it is telling us is this particular customer is high on at least some of those variables. Okay. He's high on some of those variables, hence not on all variables. Say their satisfaction score is okay, let me see if I can find this satisfaction score here. The satisfaction score is not so, I'm just trying to find where the satisfaction score is for this particular customer. What might be happening is the satisfaction of this customer may be low, but he's been a customer of long tenure, and he's a very senior customer having an age of 69. The monthly charges seems to be close to or less than average. The referrals are there. I think these characteristics are basically making the customer or the model to decide that this customer is not likely to churn. Right? Just to summarize, this customer has a high referrals. This customer has a decent monthly charges, and also this customer is quite satisfied. Right? That is a reason that the model is predicting this customer to be active, whereas in reality, this customer has been churned out. Okay. So this basically comes to the conclusion that there are certain other aspects of the of of a customer that model is not really using it to come up with the right prediction. Okay. Now we may have to bring those variables into the model and start using them, or we can be more careful about this group of customers, right? Okay, so I think that's how we have built the model. Now let me just show you how this approach, or let's just see that how this model is standing on the AI trust framework. Okay, now what I mean by that is we can generate a fact sheet for this model. Fact sheet is basically an overall description of this particular model here. Let's give a minute for this to load all the different analysis within the fact sheet. So I just got access to this dashboard. Now this dashboard, basically the first tab explains everything about this model, what variables I have taken, what variables I have used, what different algorithms that classifier has chosen to build this, how it stands on the performance. As I said, the performance is close to 97, 96%. And this also tells me that this fact sheet analysis has performed, model biasness, debiasing, and it has also used a reweighting technique to sort of like debias a particular algorithm. In certain cases, it has also identified the drift in both features and target variable. Of course, it has performed the explainability. Um, so there are no descriptions about what different security attacks, the security assessments that we have done. So these are some of the different analysis has been done on this model. That's what this fact sheet is telling me. I can first see the same data descriptions, what we have seen on the canvas as well. Um, it's the same analysis, but it is given here so that you can come back and visit and try to understand your data better whenever you see certain diagnosis issues here. Let's look into the model building. So this is the model that we have built, which had an about 96% accuracy, precision, overall 96% accurate. The precision is 97% and the recall is 98%. It's a pretty robust model. However, what you see on the right-hand side on the test score assessment, the model trust score, which is only 59 out of 100 scale. So it's a very low score. And this table is also telling me that the model has really not span out well on safety, explainability, fairness, etc. Right now, in the canvas, you have seen the explainable operators. I think those operators are used later before calculating this trust score. Now, this trust score is for a traditionally how you will build an AI system, right? So even though you may have a very high performing model in one place, but still, if you apply this framework where you are essentially assessing this model on all these different aspects, your overall trust score is quite less, right? We also see that this model is extremely high performing. Hence, on the performance dimension, this model stands quite high, whereas on the other dimensions such as safety, fairness, lineages, and etc., other attributes, this model has not really standed well on that. It has found some 10 non-compliances for safety, 6 non-compliances for fairness, and all the different metrics required for the explainability is not present in this model. Okay, so this assessment, this analysis will tell you that even though you may have a highly performing model, but it's not essentially a trustworthy model. Okay, now as a next step, we would like to see what are the specific issues of having a lower trust score. So we can go into this diagnostic bar. Now what this does is, if this page is blank, essentially it means that the diagnosis, the model the system has not identified any potential issues, but we can see the model local explanation basically lacks on false negatives and false positives. So we can try to understand. We have seen that in the canvas that especially for the high value customers, the model, I mean, high value customers was just a hypothetical example, but for certain group of customers, the model was having a lot of false negatives. So we can understand, we can see to, we can look into this analysis to see um, why is that the case. We have also looked at the biasness with respect to all the variables, but we have seen what this telling me is there is a biasness with the marital status of the customers. Basically, it is telling me that the model is more biased towards the unmarried customers. It is more likely to predict churn behavior among unmarried customers, even though that may not be true. Hence, it is detecting a bias. Just to show you a comparison, there is no bias with the gender because across different male-female section of the sample, the model is quite unbiased in predicting churn behavior. Now, what we learn from this is marital status is one variable which seems to be having issue with respect to the biasness. That's one. And we are also seeing with respect to various different features that we have used, again, we are seeing there is a drift that we are seeing between the test validation sample and the test sample. You can also see this analysis with your training sample versus your population, just to see whether have you selected a training sample which is completely or slightly or significantly different from your population, right? That's what this drift detection is about. So this is telling me that the between different training and test sample, there is a drift that we have seen in the marital status. Maybe both these issues are related, but it's good to identify that the marital status seems to be having a problem. At the same time, even the satisfaction score between the validation sample and the training sample seems to be slightly drifted, right? Let's see, there's a drift in the target variable here. I think there is a likely difference in the target as well. However, that degree is not that much. So we did essentially find a drift issue as well as the bias or fairness issue with respect to marital status here. Now, what we want to do is we want to basically essentially overcome this issue and retrain our model in order to make it more uh, unbiased or fair towards certain variables that we have identified here, right? So this is something that we have already done. So we can straight away go and take a look at the model debiasing section here. So this is the model debiasing that we have done. One first thing that you can notice is that the AI trust score on these debiased model is quite high now. It's almost 99 from initial 59 or 60. And we have also overcome the safety concern that the system has identified. We have, to an extent, we have also looked at explainability and other things. But 95 out of 100 is a decent score to conclude that this model is a trustworthy model. The second thing that you can also notice is when we have retrained the model, the accuracy from 96%, it has dropped to 92%, which is fine. It's a trade-off that we can live with. Still, 92% model is quite accurate. This also means that the model misclassification is slightly higher this time among a certain section of customers that may not be a concern for us, right? That's what it basically means. But if it does a misclassification on some high value customers, or if it does a misclassification on just because of the marital status of a customer, that would be unfair, right? So those issues are no longer exist. However, it is still doing slightly more misclassifications on other subgroup of customers, which is not of major concern for us. Okay. Of course, we can analyze those misclassifications among 8% of the sample, and then build certain guardrails around it, or we can come up with some humiliating rules. We may not want to follow what the AI system predicts for that subsample. Yeah, these are some of the things that we can do, provided we approach the model building as per this framework. Right now, so this is what we have gone so far is basically that how you can build a trustworthy model. Right now, what might happen is you might build a trustworthy model at the time of training the model. You can deploy it, and the model might perform well. But when you say you deploy the model, you basically want the model to start doing churn predictions on the real world use cases. Basically, you want the model to run, say, every 15 days or every 1 month, and want to identify which of your active customers are more likely to churn. Okay. Now there, what it might do is, of course, it takes certain inputs of those active customers, and then it comes back with a probability whether that customer is more likely to churn or not. Now, the model will behave, this model has behaved quite well on the training data that we have used, right? Of course, we have overcome some of the challenges of this training data and also how the model has learned from this training data. That means this model is trustworthy on the training data. And of course, we have tested this on various different validations. So we are fairly confident that this model will is very likely to perform in a similar fashion on the production data, but that may not be always true. So we need to monitor the model which is in production. We need to monitor for all these different aspects, right? That's something that we will look into it now. What I have is an illustration of this particular model when it goes into production. Okay. So this is the model performance. Typically, we look at performance so far, but what this trust framework is telling us is, along with the performance, you may also need to calculate this trust score across these different aspects to really identify, because we have seen it very clearly that model might be performing well, but it might be unfair, it might have biasness or drift kind of an issues that will go undetected if you only monitor performance in your production or in the training for that matter. So, so let me show you what I have on the screen. So on the left-hand side, you see the model which we have put into production, the model which is decent, carrying a 92% accuracy. And as you can see, we have set some cutoffs here on the model. We don't want the model to start uh, performing in terms of, we don't want the model to have very low accuracy beyond 0.8, which is a 80% accuracy. We want the system to alert us whenever the accuracy goes down. I think it's fairly okay that the accuracy of the training model is around this range. We have also seen this model is extremely trustworthy. We have a 95% of score. The performance, I mean, those major issues have gone, and there are still the red areas for lineages and security aspects, which is not of a big concern for us. Hence, the weightages are assigned low. If this is a concern for other use cases, the weights can be assigned higher to that, and accordingly, we can take actions on that. What I'm trying to illustrate is, now let's take a scenario when after a while, like after the launch, maybe after 2-3 months, the accuracy has been quite consistent and we are regularly monitoring it. But on the third month or fourth month, we have seen the accuracy has suddenly dropped. Okay. So as I said, you may not see the accuracy dropping, but you can still need to look into the AI trust score in order to make sure that the model is not becoming suddenly biased because there is a change in the customer usage and behavior, which is very likely, right? So you can see that the model performance has gone down. You can also see that the model is not really yeah, you can also see the model trust score is also gone down drastically, right? So this is telling me that after 3 months of data. Now, what might happen is in those 3 months, what might have happened is there must be a change in the data distribution, or there must be um, um, because of the change in the distribution, it might have been biased for certain class of customers. It can be anything. So we can go back to the diagnostics, like the way we have seen it, and start analyzing that, and then identify what could be the potential issues where this has happened, right? So let's say there is a drift in how the satisfaction has been measured. in the last 3 months, there is a change in people's ratings on the satisfaction score, and that might be one of the reason for that lower score. So what you will essentially do is you want to retrain your model by taking the most recent data and then put the model back into production, right? So this is a regular activity that anyone would do once they put the model into production. But having the assessment of trust score really gives you an idea that even it may not be an issue with the performance, but there can be an issue in the fairness or drift. In this case, what we have seen is there was an issue with the performance. The model suddenly started recalling at a very lower rate, and we have seen that this is because of the shift in the satisfaction rating. Now, this shift in the satisfaction rating could be real. Maybe there was a price change or anything like that, which has made people unhappy, and they started rating it lower, which is a real scenario. So even in that case, you have to come back and retrain your model, or it could be such that the rating scale has been changed, um, which means that people are not really unhappy, but the scale has been changed, because of which the data drift has been identified. You can be more careful about it when you push the production data into the model. You can align the scale accordingly and then push it. Then this issue will overcome. Nevertheless, in any case, I think this regular monitoring will help you to identify the potential issues on across different dimensions of this framework and helps you to resolve them immediately, right? So once we retrain the model back by overcoming that satisfaction drift, we have seen the model has come back with an accuracy of 94% this time. Even the recall has been improved significantly, and the score has been slightly increased from 80 to 84%. So one thing that you can see is there is no direct correlation between the accuracy and the trust score here, which is expected, because there is, of course, if you have a good accurate model, there is no guarantee that it is trustworthy. But I think if you have a trustworthy model, it can be reasonably accurate. Um, so that is a scenario that we are looking for. Okay, I hope I've been able to illustrate that how we have demonstrated this AI trust framework on this particular use case. We'll be happy to take any questions, feedback, or comments on this. Looking forward for it. Thank you so much for your time.